remaining part of amines we are continuing. The first reaction is diazotization formation aryl amines in presence of NaNO2 plus HCl at 0 to 5 degrees Celsius we get benzene diazonium chloride. So this is the formation. It is unstable at higher temperature, so we need to supply 0 to 5 degrees Celsius. So mechanism for this reaction, so there will be these steps. The first step is generation of NO plus NaNO2 plus HCl we are using as a reagent. This will give HNO2 or HONO that later provide NO plus nitrosonium electrophile plus water. So this nitrosonium electrophile is going to form even this method this way. So coming to the nitrosonium ion, so since it is electrophile, it attacks to the aniline because nitrogen have a lone pair of electrons and aniline leave space. So it attacks to this lone pair of electrons and make N-nitrosamine. So this is the intermediate which we get. In the coming to next step, proton transfer. So here we have NH and N double bond O. So here this lone pair, whenever it shifts this side, nitrogen get 4 bonds, immediately this bond will go to here. They will get negative charge and this H plus will shift to O minus and this bond will go back to the nitrogen. That is how we get diazohydroxide is going to form. And in the last step, just one more lone pair, if it shift towards this and this H plus ion accept OH minus ion from this, and finally we get benzene diazonium chloride. So benzene diazonium salt will be formed. So this lone pair shifted here and get N plus. In the mixture Cl minus is there, that Cl minus attacks to N plus, and that is how we get diazonium salt. So it is a synthetic reagent. It is used to make lot of other dyes. So what are the reactions with this? All those things we can discuss in here. So benzene diazonium chloride, based on the different reagents, will get different products. So C6H5OH, which is nothing but phenol. It is C2H5OH, ethanol. Ethanol becomes benzene and CH3CHO plus N2 and HCl. So here what happens is benzene diazonium chloride converted into benzene in presence of C2H5OH and C2H5OH converting into CH3CHO. It is oxidizing to aldehyde and benzene diazonium chloride reducing to C6H5H6. So that's how the redox reaction is happening in this. The similar manner H3PO2 converted into H3PO3 and benzene diazonium chloride converted into benzene. That's how we get this. And these reactions we already studied. These are called as Sandmeyer reaction. So benzene diazonium chloride in presence of CuCl. Here oxidation state of Cu supposed to be +1, not +2. So that CuCl or Cu2Cl2 will take and get the chlorobenzene. Similarly, if you take HBr, you will get bromobenzene, and if you take this one, we will get cyanobenzene, and with Ki we will get iodobenzene. Here cyanobenzene is missed, C6H5 Cn plus N2 plus HCl, and with the help of Ki we will get iodobenzene. So with the help of HBF4 we will get overheating, we will get fluorobenzene. It is very important reaction. This is itself called as Ball-Schiemann reaction. And we can also take sodium tetrafluoroborate or HBF4 to get fluorobenzene. And similarly, sees benzene diazonium chloride with water will get phenol, that too with warm water. And coming to the Gattermann reaction, even this you studied in case of first haloalkanes chapter. So Cu powder will get chlorobenzene, and similarly with reduction we will get phenyl hydrazine. So the reagent is SnCl2 plus HCl. And coming to the beta naphthol, so here onwards we are going to discuss as coupling reactions. So this coupling reaction is an example of EAS reactions. These EAS reactions are directly proportional to the electron donating groups. That means if benzene diazonium chloride are over benzene, if electron donating groups increases, this coupling reaction is going to rise. In all the cases, para hydrogen replaced and make respective die. What are those things we can discuss now? So in case of beta naphthol alone, the ortho hydrogen replaced and make C6H5. Here this is the product we get. So here beta naphthol gives bright red orange dye. So in presence of basic medium, and phenol with benzene diazonium chloride need 8 to 10 pH value to get the respective para hydroxyazobenzene. It is in orange red dye. And coming to the aniline, so here phenol, the same reaction with aniline, the pH value 4 to 5 to get the para amino azobenzene. This will be in yellow color dye. So here colors are important for the respective dyes, and even why we are using pH of the pH with phenol is 8 to 10 or aniline with 4 to 5. The reasons are very important. Those reasons we can discuss here. So the reasons are, so you can add the reasons for this. Phenol pH value is just pH value. Phenol is weakly activating group, weakly activating group, weakly activating group. But this coupling reaction is an example of EAS reaction. So strong activators are required to make coupling reaction. So in the presence of basic medium, this loss of H plus happens from the phenol and lose water and becomes sodium phenoxide ion. So that will activate the ring and increase the coupling reaction formation. That's why with the phenol pH value will take 8 to 10. Similarly, aniline case, what will happen we can see. Aniline is strongly activating group, strongly activating group. So that's why what happens if it is strongly activating group in presence of acidic medium, so the like in strong acidic medium NH2 becomes NH3 plus. Then NH3 plus is strongly deactivating group. So we will not use strong acidic medium, but we will use mild acidic medium. Like pH value is 4 to 5. So due to what reason we are keeping pH value 4 to 5? The first thing is this pH is enough to stabilize diazonium salts, because at a strongly basic medium or strongly activating case, diazotization salt is unstable. So to be stable of diazonium salt, the pH value should be mild acidic, and also not too much acidity to protonate NH2 completely. So here don't get confusion, students. The first reason is the formed diazonium salt stable at mild acidic medium. Second one, too much acidic medium if we use, the NH2 completely becomes NH3 plus. That deactivating nature of NH3 plus doesn't support for the coupling reactions. So these are the two reasons why we are going to use respective basic medium in phenol, acidic medium or mild acidic medium with aniline. Hope it is clear. Coming to the methyl orange, how it is going to form. So methyl orange is also one of the important reagent. So methyl orange is just so methyl orange, how it is going to form. Preparation of methyl orange is also very important indicator. So sulfonilic acid means this one NH2, so sulfonic acid SO3H, this is called as sulfonilic acid in presence of HCl and NaNO2, that NH2 becomes N2 plus X minus or Cl minus, and this SO3H will be remain same, and this is called 4-diazo benzene sulfonic acid. So this formed one further reacts with N comma N dimethyl aniline. So N comma N dimethyl aniline. So nitrogen connecting with two methyl groups. So this is N comma N dimethyl aniline. So this together same at para position, H plus replaced with this group. So this N2 plus attacks at para position by replacing H plus. That means this N2 plus group replacing H plus. So it is an example of this which one EAS reaction, means electrophilic aromatic substitution reactions. So the product will be like this. So N comma N dimethyl will be as it is, and at para position N double bond N, and this will be as it is. So SO3 minus Na plus. This is called as methyl orange indicator. So this is what overall what is methyl orange indicator, and also what is the purpose of conducting coupling reactions. And coming to conditions. So for this reaction also we have to maintain 0 to 5 degrees temperature, and pH weakly acidic medium is required. Same acidic medium, that is 4 to 5 pH value need to use. So this is how the final product is going to happen. Thank you. That's all, students.